Hello, everyone, and welcome to this webinar. My name is Scott Malky. I'm a senior product manager here with EC2, and today we're going to be talking about how to accelerate your iOS development with our new Amazon EC2 M1 Mac instances. Thank you for spending the time with us today. Hope you find this entertaining. So, quick agenda. The first thing we're going to do is we're going to talk about some of the challenges that builders face today when building applications for iOS or macOS or Apple platforms. We're then going to talk about, hopefully, the features in EC2 Mac that help solve some of those challenges. We will then go over how our customers have used EC2 Mac to solve those challenges as well. And then we'll get into a bit of a demo. First, we'll do a manual build to show you how you can do things all manually. We'll then automate it through various tools within AWS and some third-party tools. We will then take our application and test it on real devices with Device Farm. And lastly, we'll have hopefully some time at the end for Q&A, questions and answers. So it seems pretty packed. Let's go ahead and get started. So this is the application development lifecycle for Apple hardware. The design, code, and develop steps are fairly simple. That's what you have to do for most software projects. However, the final four, the build, test, sign, and publish steps for Apple hardware, they do require Xcode. Which does only run on macOS. And if you are an Apple developer or develop for Apple hardware, I'm sure you're familiar with this piece of software. You do need Xcode to reach some of the million apps and the billions of active devices that Apple has in the market, including things running iOS, tvOS, iPadOS, and macOS, right? Even the browser Safari to build extensions for that does require Xcode. And here at AWS, to really bring these Apple developers to AWS, we had to bring macOS to EC2. So in addition to requiring Xcode, which requires macOS, which requires Apple hardware, there are some additional challenges when building Apple applications using on-premises hardware. The first is infrastructure overhead. So if you have an on-premises fleet, you do have to manage that, right? You do have to keep track of which version of macOS is installed where. If there's updates, you have to patch all of them. You have to create users and network. If there's hardware issues, you have to replace them. And that sort of care and feeding of this hardware is just overhead, right? It requires people, it requires time. And it's not really something that you can tell your customers about, right? It's something that you just sort of have to do. A second challenge is this disparate build environments, right? So you may have one build environment for, say, your Android apps, another build environment for your Windows or Linux-based software. But Mac, because it does require Apple hardware, is sometimes siloed or sometimes just its own separate build environment that, again, requires separate management, not just from a hardware perspective, but from a software perspective. What we often see from a lot of customers is that they've been able to take a lot of their non-macOS builds up into AWS, up into EC2. Leveraging our Linux and Windows servers, but Mac has stayed on premises because of the need for Apple hardware until EC2 Mac instances were available. The last challenge is that it's not scalable, right? With any on-premises hardware, you tend to buy for the peak. You tend to acquire what you need for your busy periods. And if you are not using it, it just sits there idle. And it's very difficult to quickly scale up if you maybe underplanned for your peaks. And if it's and there's no such thing as scaling down. You've already bought them. They're sitting in your data centers or your colo facilities, and you have to again power them, and going back to that infrastructure overhead, sort of keep them up to date and things of that nature. And really, what this all leads to is slowing down innovation, right? Your developers want to be focused on the features for your applications that matter to your customers. Your developers want to be focused on making really cool apps, making really cool backends for those apps, and having to deal with this overhead, having to deal with different build environments and the operations there, and that lack of flexibility really just slows the whole thing down. How we solve that is by bringing the macOS hardware into AWS. And this is an actual picture of an Amazon EC2 Mac instance, right? This is an actual Mac Mini, the same that you could get if you went to the Apple Store today, connected to our AWS Nitro system, a building block of bespoke cards and functionality that really offload a lot of the security, offload a lot of the storage and networking capabilities from the hardware itself to these separate cards that then talk to the rest of EC2. So, EC2 Mac instances are this great combination of both actual Mac hardware and the same EC2 control plane, the same EC2 functionality, the same EC2 stability and scalability that you're used to with other EC2 instances. One of the things we're very excited about is our new Amazon EC2 M1 Macs, which is bringing Apple Silicon to AWS. So just like our x86-based Macs are using the 2018 Mac Mini with the Intel Core i7 processor, our Apple Silicon M1 Mac instances use the 2020 Apple M1 Mac Mini. And again, this is a combination of the same Mac Mini that you can get from the Apple Store, combined with the AWS Nitro system. We've gone with the 8-core model that has 4 performance and 4 efficiency cores, the highest memory available, the 16 gigabytes of RAM. And thanks to the AWS Nitro system, we're able to offer 10 gigabits of network throughput and up to 8 gigabits of Amazon EBS bandwidth. With the AWS Nitro system, we also have the Nitro security chip, a hardware root of trust that verifies the firmware, verifies all of the connectivity to the Mac Mini itself, and like you saw earlier in those pictures, the various Nitro cards. And those connect to the Thunderbolt ports on the back of the Mac Mini. Thunderbolt is really PCIe under the hood. And those function as PCIe cards that then talk to the rest of our network to enable things like VPC networking and very fast block storage. So let's talk in a little bit more detail about these new M1 Mac instances. They are available as EC2 bare metal instances. And what this means is that there's no Nitro hypervisor or really hypervisor of any sort between you and the hardware. So as a mental model, think of plugging a USB thumb drive into the back of the machine and powering it on. That's from an operating perspective, that's actually what you're doing, except that instead of a USB drive, it is a Thunderbolt to PCIe to massive software-defined storage that is EBS. But you are actually booting off of the entire Mac Mini. So there's no virtualization. There's no, this is not a virtual machine. You are actually just getting a Mac Mini as an EC2 instance. These are Mac 2 is our nomenclature for them. The previous x86 based generation is Mac 1. So the instance type, being a bare metal instance from the Mac 2 family, is Mac2.metal. You can have up to 10 EBS volumes connected. Now, the aggregate bandwidth there, like I said before, was up to 8 gigabits per second, but you can have up to 10 volumes. That is 1 boot volume and 9 data volumes. We do recommend using our GP3 or IO2 EBS types just for performance reasons. You can have up to 8 ENIs, which are elastic network interfaces. So up to 8 NICs, if you will, within the Mac2.metal instance. Again, you'll have 1 by default. That's how you connect to it. But depending on your network topology, depending on how you want to send packets around, you can have up to 8. And these are available as dedicated hosts. And what that means is that they are single tenant. So they are bare metal instances, and you first start by allocating a dedicated host, and then you can launch instances on top of that dedicated host. So the way to think about this is when you allocate that dedicated host, you are asking AWS for a Mac Mini. You are saying, hello, AWS, I'd like a M1 Mac Mini. And we say, cool, here is your Mac Mini. That is allocating the dedicated host. Now, at that point, there is no instance actually running on top of that host. You've just got the dedicated host of the Mac Mini. When you actually run an instance, either through the console or through the AWS Run Instances call, that's when we wire up that thumb drive to the back and power it on and launch that instance. The dedicated host, the underlying hardware, has a minimum allocation period of 24 hours, and that's to comply with macOS licensing. The instances running on top of that host can come and go with whatever lifecycle you would like. So you allocate the host, we give you a Mac Mini, you can launch, so again, think plug and unplug thumb drives as you need to do build jobs or things of that nature. And then when you are done with that host, you stop your instance, disconnect the thumb drive, and give it back to us. And the term there is release the host. So you release the dedicated host back to us. The minimum allocation period impacts the time that between when you allocate and when you can release. So once you allocate a host, once you say, give me a host, give me a Mac Mini, and we hand you that Mac Mini, you cannot give it back to us for 24 hours until 24 hours have passed. An important thing to know here, and we'll talk about pricing in a couple slides, is that billing is always per second. So you are not billed for the 24 hours up front. You are not billed in 24-hour chunks. The billing is always per second by the dedicated host. The instances on top of that host are no additional charge. That host is the unit of billing. So you allocate the host, the 24-hour clock starts, the billing clock starts. Instances on top of that host come and go as you would like. Some customers launch one instance and just run that the entire time. Some certainly have automation that drive launching instances and terminating instances. But as long as you have that host allocated, that's what's being charged. And again, you cannot hand it back to us until 24 consecutive hours have elapsed. Last thing we'll talk about in terms of the platform is the internal SSD on the Mac. Now, there is an internal SSD. It is soldered to the motherboard. We do not desolder it. However, we don't support it. We don't manage it. We don't monitor it. It's there. You are welcome to format it and use it if you would like. But we recommend, strongly recommend, that you use EBS for its durability, its performance. You can have up to 10 EBS volumes connected. We get a lot of questions about the internal SSD. It's there. We don't recommend you use it. That's the hardware side. In terms of software, we support both Big Sur and Monterey. So the 2020 Mac Mini that our M1 Mac instances are based on shipped with Big Sur. So Apple hardware typically only supports the version of macOS that it shipped with and later versions up until Apple drops support for that specific hardware. So the furthest back in terms of macOS support we can use for M1 Mac instances is Big Sur. However, we do support Monterey as well. We also, in our macOS AMIs, our Amazon Machine Images, support packages like the AWS CLI version 2, SSM for remote access as well. You can, and this is the same SSM that you would use for your Linux and Windows instances. So you can use things like Fleet Manager or Run Command. You can tunnel SSH over SSM. And get secure connectivity that way. It's the same SSM that you would get any place else, and it comes included with our macOS Amazon Machine Images on both Mac 1 and Mac 2. You can also just use SSH. Again, an EC2 Mac instance is an EC2 instance. So when you run that instance, when you plug that thumb drive in and turn it on, we do allow SSH through our key pairs, just like you would for Linux and Windows. We also have instructions in our documentation for how to turn on the built-in VNC server within macOS for graphical connectivity, for GUI connectivity. We do recommend tunneling that VNC access over SSH. And again, we do have information on how to do that in our documentation. We do support Homebrew in our AMIs, which is a very popular package manager for macOS. We have our own tap. So Brew comes installed. So to install your favorite software stack or whatever you need for your productivity, you can do Homebrew or just Brew install, whatever the package may be. We also support user data. So many customers like to do things at launch time rather than baking them into custom AMIs. So we have an open source piece of software, EC2 macOS init, that is a launch daemon that will execute whatever you put into the user data. So if you want to make sure that you're running, say, the latest version of a software stack, or you want to pull down some files off of S3 or things of that nature, you can put those commands into the user data, and EC2 macOS init will run those commands on instance launch, so that you don't have to create newer AMIs. And we do release new AMIs at a pretty regular cadence. We certainly test them ourselves, and we want to make sure that there aren't any breaking changes in later versions of macOS that would impact our fleet and our management of these hosts. But we do release macOS both major minor patch versions of AMIs fairly regularly. Last thing we'll talk about is pricing. So again, the AMIs, the instances, there's no separate charge for those. Just like any other EC2 construct, come with EC2. The macOS license is included. We do not charge additional for macOS. And again, like I said before, per second billing. So it's all, the host is the unit of billing, not the instance. The host is the unit of billing, and it's always done per second. The 24-hour minimum allocation period does have an impact on it, but a lot of folks tend to think that we're going to hit them all up front with that, or it's 24-hour chunks, or they sometimes get confused between the host billing and instance billing. It's per second billing for the host, always. On demand, because they're available as dedicated hosts, they are available on demand. the host dedication and host allocation functions very similarly to, say, a reserved instance, because it is your host, you have it. And again, that 24-hour minimum allocation time. Because of the dedicated host nature of it, and because of the 24-hour minimum time, we don't support spot. We also don't support reservations, RIs, because, again, you're getting functionally the same thing with a dedicated host. However, we do support both compute and instance savings plans. So if you would like to commit to a certain amount of usage over 1 or 3 years, we will give you a discount based on that usage commitment. So reach out to your AWS account team. Happy to talk to you more about that. So why AWS? Why AWS for macOS? I've told you about the hardware that we have. I've told you about the software that we have. And let's talk about how some of the specific benefits that AWS and EC2 have for macOS. So there's a few benefits that AWS brings to macOS development. I've told you about the hardware. I've told you about the software and the pricing. Let's talk about some of the specific tangible benefits you get with macOS on AWS. We loosely define them into roughly 6 categories here. And I'm not going to read all of these to you, but I'll hit the high points and we'll go from there. So automation. Right, so you've got CloudFormation or Terraform to use infrastructure as code, Systems Manager, SSM, we talked about that earlier. Scalability, right? These are totally pay as you go. You can scale up on a daily basis, potentially if there's a new version of iOS that comes out, or a new drop of your game and you want to test it and you need a ton of servers. You can spin those up, use them for a day to test all out, or a week or 2 or 3 days, however, spin them down when you're done. And it's that elasticity that we see really benefit a lot of customers. They know when their busy periods are and are able to scale up to meet those busy periods and then scale back down to sort of the steady state, day in, day out macOS building. The Amazon machine image and the ability to customize it and then bake it and launch new instances from a repository of golden AMIs saves so much time. This is what we hear from customers over and over again, is that having to manage and re-image and update and do all these sort of care and feeding of on-premises Macs, and take a best guess at what versions of Xcode and what versions of macOS we're going to need at any given time, and have people go and update them and things of that nature. It's just a huge operational overhead, and being able to just start with one of our AMIs, put in whatever version of Xcode you need, whatever versions of your own build tools and software you need, bake that AMI, create a snapshot, create a derivative AMI, and then just use that AMI to launch however many instances you need to. It just saves so much time. One thing you can also do is you can actually share the dedicated hosts across accounts through a service called AWS Resource Access Manager. So we do have customers who have very geographically dispersed development groups, and they use the same dedicated host, say for 12 hours in one part of the world, and then they terminate their instance, and then a group on the other side of the world uses it for the next 12 hours. Different accounts, different teams, but it's that same host. So rather than having to allocate more hosts, you can share that host between accounts. Again, EC2 Mac instances are EC2, right? So all of the compliance and other regulatory frameworks that you need for EC2, EC2 Mac is part of them, because it's part of EC2. Security is also a big one, right? We have Amazon VPC, right? So firewalls, stateful, stateless, NACLs and security groups, AWS IAM for real granular control over which developers are allowed to launch instances, which developers are allowed to terminate instances. When can they do that? Full auditing with CloudTrail, who spun up what when. The EBS volumes can be encrypted through our key management service, KMS. So you get significantly higher security posture, again, that you get with any other EC2 instance, this time with macOS. And lastly, and again, this is also, I think, a pretty big one, is things like CloudWatch, things like EventBridge. So the ability to really monitor network bandwidth, disk bandwidth, CPU usage, auto scale based on CPU usage, initiate actions based on EventBridge. Use EventBridge to terminate instances. Use EventBridge to release hosts. Right. Really, there's a lot of very cool operational and monitoring workloads that you can do with Macs on EC2. Hopefully, the past few minutes have convinced you that an EC2 Mac instance is much, much more than just a Mac in the cloud. But don't take my word for it. I'm going to put up a few slides now of customers and what they've said about their journeys from on-premises to EC2 Mac. First off, here's a small list of some of our customers. They've been very successful with EC2 Mac, and we are thrilled to have helped each of them focus more on their core business of releasing cool games or building cool apps, building features within their cool apps for their customers, rather than having to spend time and energy just making sure their Mac build fleet is up and running. I specifically want to call out our partners here as well. Teradici, they have a macOS AMI for their remote desktop solution on the AWS Marketplace. The same thing with the Center for Internet Security, CIS. They have a hardened macOS AMI on the AWS Marketplace, and we are working very closely currently with BuildKite for CI/CD workflows. Goldman Sachs, they spoke at this past reInvent with us about EC2 Mac instances. I'm not going to read this whole slide to you. There's a few coming up that have similar amounts of words, but I will read out the highlighted section. Right, builds are more reliable with a build time reduction up to 50%. 50%. It's pretty big. Pokemon. Right, this is Unity CI/CD, 400% faster builds with Unity on EC2 Mac. Just massive performance increases. Intuit, right? They've moved their entire build and test pipelines to EC2 Mac, 30% better performance. Right, thanks again to that elasticity that we provide and multiple availability zones, being able to get closer to where those developers are. Twitch, right? Again, faster and roll out a new AMI faster, 4 times faster. Reduce the fleet size by 50%. Right. So again, you're talking these are pretty massive numbers for pretty massive operations, which lead to a lot of savings. Riot, Legends of Runeterra, is built on EC2 Mac, 100% AWS across all platforms, right? So macOS, Android, Windows, and it really unified their build environments, right? So now they go to a one central pane of glass and can see all their builds and monitor all their builds in one place. All right, so you've heard me talk about our new M1 Mac instances. You've heard from customers about how EC2 Mac instances have improved their build, test, sign, and publish workloads. I'd like to take a few minutes now and actually get hands-on and show you how these instances can help you. For the demo, I'm going to be using the Getting Started with AWS tutorial on building an iOS application. We're going to create an application using AWS Amplify, a set of tools that make it really easy to build mobile backends in the cloud serverlessly. The URL is there at the bottom, aws.amazon.com/getting-started/hands-on/build-ios-app-amplify. If you would like to follow along at home. We will be fast forwarding through all the parts where the build just happens and everything rolls by. But this is what we'll be doing, and we'll be showing it off on our new M1 Mac instance. All right, for this demo, we are going to use a demo built on AWS Amplify called Build an iOS Application. It's on the tutorial page, as you can see here. The code is actually up on GitHub. It's fairly straightforward. It's just an Amplify project. You can see the source code. You can look through it. All the scripts that we're going to use to build and test are there. Please feel free to review it. It's up there now. Everything to build and do secrets and everything is there in the code, even connecting to App Store Connect and things like that. The application is distributed via test flight. This is actually my phone. You can see that it's a simple note-taking application, picture, title, and the text. The designer chose to put this fairly awful green background on it, and for the demo today we're going to remove the green background and republish it and see how this all works. So we're going to make the change in the code here. We're going to push that to GitHub. GitHub's going to trigger a code build CI/CD pipeline that's going to go through App Store Connect, and then at the end we'll see it back on there. The first thing we're going to do is delete this offending line of code here. You can see in the preview that the background is now white and looks better. And in the real world, I would probably build and test this locally, but this is a demo, not the real world, so we're going to go ahead and just commit and push. So I go to the source control, I give a commit message because I am a good developer and always put a commit message in. The commit message is remove green background, simple enough. I commit it, and then I push up to GitHub. And now that the change is up on GitHub, we can go back to it, and you can see here that the page, after being refreshed, shows that there is a change from 24 seconds ago. So the change has been taken on GitHub. And from GitHub, that commit and push triggered a AWS code build job. I have a project here for my macOS builds, and once I refresh this, you can see that the build is now in progress. The change has been detected and automatically triggered the build automatically. So the build is not actually happening in code build. Code build normally supports Docker containers with Linux, but we're using a very simple script here in code build to actually send that build command to an EC2 Mac instance. I can observe in the code build console the different steps and stages and the output of the build. So here's the builds. You can see these are my build spec YAML file. So we've got install, pre-build, build, and post-build. And I'm using a simple command line shell script to pass it through. And you can see how each shell script has the name that corresponds to the phase here. And we are using SQS to send information back and forth between the code build service and the EC2 Mac instance. So if we look here at the code build console, you can see the actual output going back and forth. So back in the EC2 console, you can see I've got my EC2 Mac instance. I grab the IP address from the EC2 instance detail, and then I can go into my terminal here on my laptop and I SSH into it. And you can see I've greeted with the MOTD, and if I look at the log file here, and I can observe the build as it's going. Here all the logs are getting generated, and I can see builds happening. I go back over to code build, and I can also see the log file into code build. You can see the results of the various dependencies getting installed, things of that nature. So we're going to fast forward a little bit. So the whole process took about 10 minutes roughly, and then we go back into the build status. We get the build status as success. We'll go over to App Store Connect and we'll see the push. You can see it's currently processing. So we've pushed a new binary up into App Store Connect, and it's running some sort of generic checking and things of that nature before it gets over to me. I get a test flight email that says a new version is ready. I go over to my phone. I see there's a new version. I open my test flight. I open the new Amplify Getting Started application here. And you can see now the notes open and there is no longer a green background. That's an end-to-end demo. So you can see I had it running on Xcode on my phone. I made the change in Xcode, went through code build, built on an EC2 Mac instance, went to App Store Connect, went into test flight, and then I opened it up in test flight, opened it, and saw the change there on my phone. So in summary, EC2 Mac instances combine the power of a physical Mac Mini with the scalability, security, reliability, agility, elasticity of EC2. They are EC2 instances like any other EC2 instance out there. It is a Mac Mini just like any other Mac Mini out there. EC2 Mac instances remove operational overhead, that undifferentiated heavy lifting, as we say here, and they increase your innovation. They let your developers get those cool features out to your customers faster and easier. We also have both Intel and Apple Silicon Mac Minis. Our Mac 1.metal instance type is powered by the Intel Core i7, x86 based, and our Mac 2.metal instance type is powered by the M1 processor, ARM64 based. Well, we've given you a lot to talk about, a lot to think about. If you have any questions, we'd be more than happy to answer them now. Thanks everyone for coming today. Hope you found it entertaining, enjoyable. Hope you learned something. Please go ahead and visit aws.amazon.com/Mac to learn more information. Thank you for your time.